calendar. So today we're doing topics 24 and 25. Tomorrow, topic 26. And then on Thursday, you'll have a quiz. And then Friday, I have done topic 27. I will actually not be here on Friday. You'll have a sub. So, if anything, I'm going to record that lesson ahead of time for y'all to still do using Google Classroom in class, or you can watch it at home and work on homework in class on Friday. Alright, so let's get ready for topic 24. This is the first day of Unit 3. And I do think you'll like today's lesson. So, Unit 3, topic 24, and we will also get to 25. No longer, well, we still have to use the formal definition of a derivative, where we're looking at the limit as the change in x approaches 0 to find the derivative of the function. But no longer do we always have to use that to find the derivative. We are going to learn rules to find the derivative of a function. So the first rule we're going to look at is called the constant and power rule. Alright, so if I look at a function that's a constant, let's say f of x equals c, and let's say this is c right here, then I know that's just a horizontal line through c. So what is the slope of this horizontal line? 0. So the derivative of c, no matter what it is, since it's constant, is always going to be 0. So we have the constant rule. And up here we can go ahead and write f prime of x equals 0. Because the slope of a horizontal line is always 0. So our constant rule, we can notate as d over dx of c is equal to 0. So the derivative of a constant function is always 0. And then our power rule. So to find the derivative of a power, so our rule, d over dx of x raised to the power of n, I can find the derivative of this by moving n to the front and multiplying it to x, so n times x, and then decreasing the power by 1. So example, if f of x is equal to x cubed, without doing the formal definition of the derivative, f prime of x will equal, I bring my 3 in front and write it as 3 times x and decrease my power by 1, so 3x squared. Is it looking better already?
Yes.
So examples. Find the derivative of each. Now this doesn't mean we can forget the formal definition, because I guarantee you there's going to be a question on the AP test that uses the formal definition of the derivative. So we'll still practice with it throughout the year. So find the derivative of each. So number 1, I have f of x equals 2x squared plus 3x minus 6. So I'll just use my power rule and my constant rule. So f prime of x will equal, so on 2x squared I bring my power to the front, 2 times 2 is 4, so 4x, decrease my power by 1, so 2 minus 1 is 1. I don't have to write the 1, I just did it in my notes just to show you. And now 3x, well right here the power is 1. But this is also, I don't even have to really think about that power rule. It's a linear line. What's the slope of 3x? 3. So it's going to be plus 3. But if I think of my power rule, 1 times 3 is 3. 1 minus 1 minus 1 is 0. Anything to the 0 power is itself. So again, it is just 3. And then the derivative of a constant is 0. So I don't have to write minus 0 at the end. So that's my derivative.
This is so much easier.
Yes. The rules are so much easier. It's the algebra, though, that sometimes will get us. So we do look at harder, more complicated expressions. So number 2, f of x is equal to 1 over x squared. So anytime the variable with the power is in the denominator, we're just going to rewrite it using our exponent rules. So I know this is the same thing as x to the negative 2. Remember, if you take the reciprocal, you change the sign of your exponent. So now using the power rule, so f prime of x will equal, I bring my negative 2 to the front. And then negative 2 minus 1 is negative 3. So I have negative 2x to the negative third power. And I'm going to rewrite that by making the power positive. So negative 2 is my coefficient in front, so it'll stay in the top. And then now I can write x to the power of 3 in the bottom. Number 3, we have y equals negative x to the 4th over 2 plus 3x cubed minus 2x. Alright, so I know negative x to the 4th over 2 is the same as negative 1/2 x to the 4th. So I can rewrite that if I don't want to do it in my head. And now to find the derivative, I'll use my power rules. So since I started with y, I'll denote the derivative as y prime. Oh, does anyone know the derivative of Amazon?
What?
Does anyone know the derivative of Amazon?
No.
Amazon Prime! Okay, I had to say that. Okay, so now using my power rule. So move the power, multiply it to the front. So 4 times negative 1/2 is negative 2. So I have negative 2x, 4 minus 1 would be 3. What's the derivative of 3x cubed?
9.
Good,
Oh, wait,
9x
yeah.
squared. 3 times 3 is 9, decrease the power by 1. And what's the derivative of the minus 2x? Minus 2. So there's our derivative. Okay, number 4. Write the equation of the tangent line to f of x equals 2x to the 4th plus 3 at x equals 2.
This is for random.
Thank you. So write the equation of the tangent line. We're going to stop and do what?
Write the formula.
Y minus y1 equals m times x minus x1. That's what I'm writing. So I need my point, and I need my slope. They gave me the x value of my point. It's at 2. So if I plug 2 into my equation, what is f of 2? 2 to the 4th is
16,
times 2 is,
32,
plus 3 is,
35.
and then now I need my slope, which is gonna be f prime of 2. I need my slope at x equals 2. So now f prime of x, using my power and constant rule, what's the derivative of 2x to the 4th plus 3?
8x cubed.
Good. And then the derivative of 3 would be 0. So now f prime of 2, 8 times 2 cubed. 2 cubed we know is 8. 8 times 8 is 64. So there's my slope. So now I'm going to label my point, x1, y1. I've got my slope. Plugging it all in, we have y minus 35 equals 64 times x minus 2. And remember, we can leave our answer just like that. We don't have to get y by itself if it says to write the equation of the tangent line. So a lot quicker when we can just use that constant and power rule. Okay. So number 5. We got 5 and 6, and then we'll move on to the next rule we'll learn. Write the equation of the tangent line. To the graph of the function f of x equals 1 over 2 times the cubic root of x squared, where x equals 8. Alright, so I'm going to take this piece by piece. Write the equation of the tangent line. So I know I'm going to write y minus y1 equals m times x minus x1. I need my point where x is equal to 8, so I need to find 8, f of 8. And then I need my slope, which is going to be f prime of 8, because I need my slope at x equals 8. Okay, so let's start. We can easily find f of 8 to get our point. So if I plug 8 in, 8 squared is 16. I mean, not 16, 64. And the cubic root of 64 is 4. 2 times 4 is 8, so 1/8. Alright, f prime of 8. So if I'm going to find the derivative of this, I need to rewrite it to where I can see my power. So first, remember, you can rewrite the cubic root of x squared as 2 times x to the 2/3. And then now, I can rewrite it using my negative rule. So my coefficient is 1/2, and I'm going to write it as x to the negative 2/3. And now we can use the power rule to find the derivative. So f prime of x, I multiply my power to the front, so negative 2/3 times 1/2. I'm going to write out step by step what to do. And then subtract 1 from my power, which I'm going to write as 3/3. So f prime of x will equal, remember when you multiply fractions top to top, bottom to bottom, so negative 2 times 1 is negative 2, 3 times 2 is 6, and then negative 2/3 minus 1, so negative 2 minus 3 is negative 5, and my common denominator is 3. So it's the negative 5/3. Okay, we can simplify this now because we are going to be plugging into it. So this is the same as negative 1/3 x to to the negative 5/3. I haven't simplified that yet. And so now moving the negative 5/3 to the denominator, so I have negative 1 over 3 times x to the positive 5/3. Or how would you write that as a radical?
The cubic root of x to the fifth.
Good, the cubic root of x to the 5th. It's that rule, x to the m over n is equal to the nth root of x to the m. Okay, so now we can plug in 8. So f prime of 8. What is negative 1 over 3 times the cubic root of 8 to the 5th? Well, I definitely don't want to calculate 8 to the 5th, but instead, what's the cubic root of 8? 2. So I want to think of it as 2 to the 5th. And what is 2 to the 5th?
60.
32.
Do what?
32.
Oh,
32. So negative 1 over 3 times 32, which is
64. Oh, wait, no. Why am I so dumb today?
one more time.
96.
96. So there's my what?
Slope.
My slope at 8. So now putting it all together, I have y minus 1/8 equal to negative 1 over 96 times x minus 8. All right, last one for this lesson, and then we'll go on to our next rule. Are y'all done with this page? Okay. So number 6, determine the points or point, if any, at which the function has a horizontal tangent line. And my function is f of x equals, on top, 2x cubed minus 3x squared plus x divided by x. Alright, so let's interpret the question. What is it asking me to find? Determine the points, if any, at which the function has a horizontal tangent line. I know the horizontal tangent lines represent slopes of what? 0. So I want to find when is the slope 0. So we need to find and solve f prime of x equal to 0. So to get f prime of x without using the formal definition, I want to make this a power constant equation. So notice that each one of these has an x in it, so we can factor and divide it out. So I can rewrite this by factoring x out of the numerator and writing it as 2x squared minus 3x plus 1. Don't forget to factor it out of itself, over x. Now the x's divide out, and so I can take the derivative of 2x squared plus 3x plus 1, minus 3x plus 1. So what is the derivative?
4x minus 3.
Good. And now if I set that equal to 0, then I'm going to find where's my horizontal tangent line. So add 3 over and divide by 4. And notice the question says determine the points. So my answer has to be given as a point. This is the x value, so how am I going to find the y value?
Plug it into f of x.
Yeah, plug it in. And we can plug it into the simplified equation. So So now what is f of 4/3?
How'd you get
Wait,
4/3?
yeah, wouldn't it be 3/4?
Oh, yes, I'm
Sorry.
making little mistakes too. 3/4, divide both sides by 4. So what is f of 3/4? So 2 times 3/4 squared minus 3 times 3/4 plus 1. So 3/4 squared is 9/16 times 2 would be
18/16.
18/16. 3 times 3/4 is going to give us minus 9/4 plus 1. So let's make these all have a denominator of 4. To reduce this fraction down to, can you write that one as a 4?
Oh, wait, no, you can't.
So all as 16ths.
Yeah.
So times 4. 9 times 4 is 36. 4 times 4 is 16, plus 16/16. And what do we get?
Negative
What do I get?
Negative 2/16. And
Which
then
reduces to
Negative 1/8.
1/8. So what's my final answer?
3/4.
Good, that's the point where f of x has a horizontal tangent. So f of x has a horizontal tangent at 3/4 negative 1/8. Okay, so now we're going to look at what's called the product and quotient rule. So this is how you would find the derivative when you're multiplying two functions together, or you're dividing two functions together that can't be simplified, or if you're multiplying like trinomial times a trinomial. Do you want to go through and multiply all that together? So this is topic 25. It's called the product and quotient rule. Alright, so the product rule, we'll start with that. So if I have f of x times g of x, that's when I would use this rule. And so I'm going to write it as the derivative d over dx of f times g is equal to the first times the derivative of the second plus the second times the derivative of the first. So you'll memorize that same. So first times derivative of the second plus the second times the derivative of the first. Alright, so practice saying that when you're doing this somewhere. First times the derivative of the second plus the second times the derivative of the first. So example number 1. Find the derivative of h of x equal to x squared plus x plus 1 times x squared plus 2. So So yes, I could go through and multiply this together and use the power rule, or I can just consider this to be the first f and this to be the second g and find the derivative using my product rule. So that will give us h prime of x equal to the first, so I'm just going to rewrite it, x squared plus x plus 1 times the derivative of the second. So what's the derivative of g?
2x.
Just 2x. Plus the second, so x squared plus 2, times the derivative of the first. So the derivative of f would be 2x plus 1. And then now we can simplify it. So 2x distributed would give us 2x cubed plus 2x squared plus 2x. And then right here we have to FOIL. So plus 2x cubed plus x squared plus inside 4x plus 2. And then combine our like terms. So we have 4x cubed plus 3x squared plus 6 plus 6x plus 2. So I don't know, maybe that one would have been easier to multiply and find the derivative of the power and constant. Example 2. We have y equals the square root of x times 3x squared minus 1. So always have to rewrite radicals as their fraction powers. So the square root of x will rewrite as x to the 1/2. And then 3x squared minus 1. Alright, and now let's use the product rule to find the derivative. So y prime will equal first times the derivative of the second, so x to the 1/2, times 3 times 2 is 6, so 6x, plus the second, 3x squared minus 1, times the derivative of the first. So what's the derivative of x to the 1/2? 1/2 x, 1/2 minus 1 is negative 1/2. So are we good so far seeing the first step?
Mm-hmm.
And now just simplifying. This one might have been easier to do the other way. So y prime will equal x to the 1/2 times x to the first. What do we do to their powers? Add them. So I can think of that 1 as 2 over 2. And so this is 6x to the 3/2. Now moving to the next one, plus distribute 1/2 x to the negative 1/2 to 3x squared. So 1/2 times 3 is 3/2. X squared times x to the negative 1/2. What is 2 plus 1/2?
Negative 3, or no,
3/2.
3/2.
Yeah. That one we can see 2 minus 1/2 is 3/2, 1.5. And then now anything times 1 is itself, but it is negative. So minus 1/2 x to the negative 1/2. Okay, so we're almost done. We've got like terms. So what is 6 plus 1.5? halves?
15.
15 halves, so y prime equals 15 halves times x to the 3 halves minus 1 half x to the negative 1 half. Or we can rewrite that as, and this is where, if I'm on a free response, I'm going to stop here. You can actually stop here on a free response question. If it's a multiple choice, though, you're going to have to know what's the simplified answer. So this one could also be wrote as 15 over 2 x to the 3 halves minus 1 over 2 times the square root of x, or x to the positive 1 half. You could also see this one wrote as, so just the algebra now is all we're doing. 15, I'm going to rewrite it right here, 15 over 2 x to the 3 halves minus 1 over 2 to the x to the 1 half. And now if I made a common denominator to write this as one fraction, what would it be? So let me rewrite this as 15x to the 3 halves on top over 2 minus 1 over 2 to the x to the 1 half. So I could multiply x to the 1 half to top and bottom. Which would give me 3 halves plus 1 halves is just 2. 1.5 plus 0.5 is 2. So 15x squared minus 1 over 2 to the x to the 1 half would also be an answer to this one. So we'll work on those fractions in our algebra. Alright, so now our quotient rule. So we saw what we do when you're multiplying two functions. So our quotient is when we can think of the function as the division of two functions. So like f of x divided by g of x. So d over dx of f over g is equal to the second times the derivative of the first minus the first times the derivative of the second, all over the second squared. Okay, so another way this one is said, that's a catchy phrase. So this would be considered high over low. So and remember we use d for the derivative, so low d high minus high d low over low squared. If you Google quotient rule, easy ways to remember, you'll find one that you like. There's one also called, I can't remember, but that's one. Low d high. And really, if I can just remember the first part, then I can remember the rest. Low d high minus high d low over low squared. So just remember, low d high. Low d high. So y'all may want to look up some sayings for the quotient rule and figure out what's the way I can remember it. Alright, so this will be example 3. Find the derivative. So if y equals x squared plus x minus 2 over x cubed plus 6, find dy dx. So that's just another notation for the derivative. So I'm going to remember, since it's division, I have f over g, low d, high to get started. So dy over dx will equal low, meaning the bottom one first. So x cubed plus 6, low d high, so the derivative of the top. So x squared plus x minus 2, the derivative of that will be what?
2x plus 1.
And now minus high d low. So high is x squared plus x minus 2. The derivative of the one on the bottom is what?
3x.
3x squared.
Oh, 3x squared.
And all over g squared. So x cubed plus 6 squared. And then again, if this is a free response question and that's all I gotta do, I'm leaving it like that. I'm not risking making an algebra mistake. But we'll work on our algebra. Or if I was using this to find f prime of something, I would definitely want to simplify it too. So, FOIL the first part. So first, 2x times x cubed would be 2x to the 4th. Outer, x cubed times 1 is x cubed. Inner, 6 times 2x is 12x. And last gives us 6. And then now distribute, and I'm going to do a minus sign and then in parentheses so I don't forget, everything will be distributed to that minus sign. So 3x squared times x squared is 3x to the 4th plus 3x cubed minus 6x squared, still over x cubed plus 6 squared. I'm leaving that one like that. And then now distributing my minus sign would make this a minus, and a plus. And now I can combine like terms. So dy over dx will equal, I have 2x to the 4th minus 3x to the 4th, so negative x to the 4th. X cubed minus 3x cubed will be negative 2x cubed. Then I have 6x squared, positive 1, positive 12x, and positive 6, all over x cubed plus 6 squared. Okay, the next one I really want to get to. This is our last one, and it's kind of wordy, but it's an important question. So example 4. Determine if h of x is increasing, decreasing, or constant. And I'm going to abbreviate those. At x equals 3, if h of x equals f of x times g of x, and f of 3 equals 5, and g of 3 equals 6, and f prime of 3 equals negative 2, and g prime of 3 equals 1. So determine if h of x is increasing, decreasing, or constant at x equals 3 with the following information. So when do I know if a function is increasing?
If
It's
derivative
positive.
is above zero.
If its derivative is positive. Decreasing if it's negative.
And constant if it's zero.
Constant would be a slope of 0. So I have to know my derivative. So I need to know, well, what is h prom of x? H of x equals f of x times g of x. So h prom of x will equal, y'all remember the rule? First times derivative of the second plus second times derivative of the first. And I want to know, is it increasing or decreasing at x equals 3? So I'm going to plug in 3. So h prom of 3 will equal f of 3 times g prom of 3 plus g of 3 times f prom of 3. And then now I'm going to use all that extra information they gave me. So just looking above, f of 3 is 5, so 5. G prom of 3 is 1, plus g of 3 is 6, and f prom of 3 is negative 2. So 5 times 1 is 5, plus 6 times 2 is negative 12. Negative 12 plus 5 makes negative 7. So now we can answer our question. What is h of x doing at x equals 3? Decreasing. So h of x is decreasing at x equals 3 because what justifies it?
The derivative is below.
Yes, h prom of 3 is less than 0. Alright, we will stop there, and I will be sure and post these homework assignments and their due dates in Google Classroom.